If it looks like I'm sweating, that's because I am. It's actually minus 40 outside today, and I've got the heat cranked in this place to try and get rid of the chill. And fun fact, Fahrenheit and Celsius both meet at minus 40. So in other words, when it's minus 40 degrees out, it's minus 40 Fahrenheit or Celsius. Alrighty, the part that so many of you have been waiting for, the construction of our mobile robot platform or smart car. Now in your kit, you got a mini kit for a mobile robot. You'll need all of these parts. There's the body, which has a laser cut plastic piece. There's 2 drive motors, 2 drive wheels, a dolly wheel, and a bag of parts containing a battery holder, some standoffs, screws and nuts, and even an ON/OFF switch. And you might have even received some Chinglish instructions. Now, the body itself is actually clear plastic. There's a masking on it to protect the plastic from scratches and stuff. You can peel that off if you want. You can peel it off both sides, or you can leave it if you want. It doesn't hurt anything. I'm leaving mine on for a couple of reasons. The biggest reason is so you can easily see everything on camera for this assembly video. Now, the first thing I want you to do is solder wires onto your drive motors. You may or may not have received some wires in your robot kit. Some had it, some did not. If it doesn't, just use telephone wire or whatever wire you have. They need to be at least 12 centimeters or 5 inches long. Longer is okay and better. Mine are going to be pretty tight fitting for the job. These might be tricky to solder on. I know this motor was a real pain. I think there was oil on the connectors. So the secret to success here is clean those connectors real good before you try to solder the wires. Wire color doesn't matter, but you want to keep track of the polarity of the motors. Here's why. I'll slap a wheel on here. Let's say the wheel is mounted and it's turning this direction to move forward. Now, the motor on the opposite side is exactly the same, only flipped over. We want the wires on the inside of the body. So if the motor is spinning the same direction as the other, notice that the wheel is now driving backwards. We want both motors to drive in the same direction in unison. Now, we can accomplish that a couple of different ways. We will be using the H-bridge board to drive the motors, so we can simply reverse the motor direction using our program and the H-bridge. Or we can wire the 2 motors, the 2 drive motors, so they have opposite polarity to each other. That's what I did here. I've got the green wire and the black wire both designated as the negative lead for the motors, because green is a conventional color for ground and black is a conventional color for negative or ground. I also happen to use red, a conventional color for positive, as the positive lead on one of the motors, but I was just using telephone wire, which only had red, green, black, and yellow to choose from. So yellow and red are my 2 positive wires, while the black and green are the negative wires. The drive motors will get mounted to the body here like this, and I want the wires on the inside of the body. So notice that my designated positive wires are on the inside and closest to the body for both motors. I'm doing this strictly so I can keep track of rotational direction on the motors when I wire them up. Now, in your robot kit, you'll also have received these slotted wheels. These are called encoder discs, and they simply slip onto the axle on the side of the drive motor when mounted on the body. And we're actually not going to use these, but keep them. Don't throw them away. We'll be using these in the 5th course when we talk about navigation. Now, we'll see shortly when you want to use them and why. For the moment, these may or may not easily just slip off of the shaft, and there's nothing holding them on there because we don't have the infrared encoder attachment. That doesn't come with the kit. Those are bought separately because, as you'll see, you don't need them except for precision navigation. Now, here's one I've assembled, and I installed the infrared encoder reader. It is an infrared emitter detector pair, an infrared LED on one side pointing at an infrared photodiode on the other side, and the encoder wheel slots in between them. So now as the wheel is turning, we can detect the breaking of the light beam by the slots in the encoder wheel. So we can measure both speed of rotation and how far the shaft has rotated, and thus how far the wheel turned and how far the robot has traveled. So when the reader is in place, it'll hold that encoder wheel centered, but we don't have one. So the encoder wheel could just fall off the shaft. So just leave it and keep it for later. You may or may not have received one of these reversible screwdrivers in your robot kit. Some of the kits had it, others didn't. It doesn't matter. You'll need a fairly fine Phillips screwdriver. That's the Star Point screwdriver. Check to see if it fits the machine screws before you go to use it. You should have a Phillips screwdriver already from course 1. Even if you didn't, get one of these fancy schmancy screwdrivers in the kit. Now, these plastic pieces are also covered in masking that you can remove. Oh. Are for mounting the drive motors. You'll find 4 long machine screws with nuts in the little plastic parts baggie. And simply put the one motor mount through the slot. Take the other motor mount and run the machine screws through its holes, and then through the holes in the motor with the wires on the opposite side of the mount. Then through the other motor mount, put nuts on the machine screws and tighten it all down like this. So remember, standard screws, when looking at the screw or nut, to tighten it, turn it clockwise so the top of the screw or nut is turning to the right. To loosen it, top to the left. So righty-tighty, lefty-loosey is an easy way to remember. So with the motors mounted, the wires should be on the inside, preferably with the positive wire on each motor closest to the robot body. If you made a mistake and got one of the motor wires backwards so that the designated positive wire is actually, farthest from the board and opposite of the other motor, don't fret. Just remember that for later, okay? We'll simply hook up that motor's wires backwards when we connect it to the H-bridge board, because that's a lot easier to do than unsoldering and resoldering the wires on the motor. You can now mount your wheels on the outside motor drive shafts. Notice that the shaft has flattened sides, and so does the hole in the wheel hub. So line up the flats of the hub and the shaft, and then just press it on the shaft. Next, we'll mount the rotating dolly wheel. Now you'll need the wheel itself plus 4 standoffs and 8 of the small wide head machine screws. I'd recommend putting them on the dolly wheel mount itself first, but leave everything loose. The easiest thing is to just run the machine screw in through the wheel side of the mount, and then just hold it with hold it with your fingertip, and then screw the stand off most of the way, remembering to leave it loose. Quick tip when working with any nuts, machine screws, or in this case, standoffs, if you're having trouble getting the thread started, try slowly rotating it backwards until you feel it sort of skip as it drops down when the threads line up. Now you can rotate it forwards, clockwise, in a tightening direction, and the threads won't be cross-threaded. So go ahead and get all the standoffs started, but remember to leave them loose. All right, we now mount this to the body on the same side as the motor mounts. The reason you left the standoffs loose is so you can get them to line up with the holes and put the same kind of flathead screw through the holes. Notice the dolly wheel flange is wider in one direction than the other. You'll see it only mounts one way to line up the holes, and that's width-wise. Okay, so there it is, width-wise relative to the body. Incidentally, this is the back of the robot. This is the front. So using your screwdriver, get all 4 screws started into the standoffs. And once all the screws are started, you can then tighten everything down on both the board and the dolly wheel flange. Now we'll mount the battery pack. Now, depending on the body you received, you may be able to mount the battery pack on the bottom of the board. The body designs varied slightly between orders that I made for the kits, and so some bodies have enough space between the motors, like this one, to fit the battery pack. So if you can, I'd recommend mounting the battery pack on the bottom of the body. As you'll see, the body is about to get real crowded. It's nice if we can tuck away the battery pack on the bottom instead of the top, but chances are you have to mount it to the top. No biggie. You've got 2 small head screws and a couple of nuts left. These go through the holes in the battery pack. Then through these slots in the body. Go ahead and mount it, tightening the nuts while you try and keep the battery pack roughly centered. And it's probably best to have the wires pointing forward. The next step is optional, and I recommend it, but with one caveat. We're going to need every square centimeter on this body plate. We have to find spots for the Arduino, the H-bridge board, other sensors like the infrared sensor, which we're going to use first, or the ultrasonic sensor, which we're going to use a few lessons later, once we learn about libraries. Now, there is an ON/OFF switch in your kit, and it just clicks through this square hole right here from the top down. It is very nice to have an ON/OFF switch. However, it takes up more valuable space on the smart car body. So your choice. I don't know what to recommend here. I'm going to install it, but if you want to save space on your car body, you can either leave it off completely or just leave it hanging on its wires. That way it doesn't take up the space on your board. If you leave it off completely, you can just pop one of the batteries out to turn off the power. So once you've got that installed, we'll simply solder the positive wire from your battery to one side and then have a wire coming off the other side.